Hey 17C students, here is a video on implicit differentiation, not where we're trying to find dy dx using negative fx over fy, where we're trying to find del z del x or del z del y. In fact, we'll do both. So let's do del z del x. And the idea here is that x and y are both independent variables, but z is a function of x and y. So that when we differentiate z with respect to x or z with respect to y, we have to think of, oh, it's really some function of x and y. So when we take the partial with respect to x, so I'm going to think of this as xy times z. So I have the derivative of xy, which is just y, right? Derivative of x is 1, y is a constant. Derivative times z, right? Product rule. So it's derivative of this times this, plus this times the derivative of this, which is del z del x. On the right hand side, the derivative of the natural log of some stuff is 1 over the stuff times the derivative of the stuff. The derivative of x squared is 2x. The derivative of some stuff cubed is 3 times my stuff squared times the derivative of my stuff. And I was writing del z del x. I think I'm just going to write zx because it's a little bit more notationally easy to write. We have to make sure we recognize zx is not the same as z. Plus the derivative of y squared is 0. And then we're going to do the algebra to solve for zx. So I circle my zx's to make sure I keep track of them. So there's the zx, and there's the zx, or is del z del x. So we have to distribute the right hand side. So I have yz plus xy zx equals 2x over x squared plus z cubed plus 3z squared zx over x squared plus z cubed. I'm writing the zx out here because I know I'm going to factor out eventually. Bring your zx terms to one side. So I've got this and this. Doesn't really matter which side you pick. You might multiply everything by x squared plus z cubed. That is an option. It might make things look a little nicer. I think I might do that. So I'm going to write this at, gosh, it's such a pain though. But it's probably worth it. Ugh. Let me do it not that way, and then maybe I'll do the other one doing it that way, because it's kind of gross. So let's see here. So I want this minus that, so I have xy minus 3z squared over x squared plus z cubed. And I'm going to factor out the zx in that same step, right? It would be xyzx minus 3z squared over that times zx. Factor it out. Equal to 2x over x squared plus y cubed minus this yz here. Finally, solve for zx. So zx equals all this divided by all this. Yeah, and I think actually maybe multiplying by x squared plus y cubed at the end here is going to be easier. So it's this divided by this. It's an xy minus 3z squared over x squared plus y cubed. It's kind of gross. So you could leave it like that. It's kind of nasty. You could multiply the entire top and bottom by x squared plus y cubed. My z turned into a y somehow. I'm sorry, that should be x squared plus z cubed. That's a z. Sorry, good thing I caught that mistake. That's a z, that's a z. Okay, so it should be times x squared plus z cubed over the same thing. So when I do that and distribute it, so this times that is going to cancel out, and you're going to get 2x. All of this times this is we're going to distribute. It's going to be minus yz times x squared, so minus x squared yz, minus yz times z cubed, so minus yz to the fourth, over, same kind of deal on the bottom, this times this is going to be xy times x squared is x cubed y, xy times z cubed is xyz cubed, and all of this times x squared plus z cubed, the denominator cancels there, and you get minus 3z squared. So that would be your del z del x. To find del z del y, we're going to do the same sort of thing. So, got the same other function. I should have written it ahead of time in the back. It's xyz equals equal to the natural log of, was it x squared plus z cubed? Yeah. Plus y squared. Now we're going to try and find del z del y, which is zy. So taking the partials with respect to y, so now x is acting like a constant. Derivative of xy is x times leave z alone plus leave xy alone. Derivative of z is zy, or the partial of z with respect to y. Derivative of the natural log of some stuff is 1 over the stuff. Gosh, you keep on to change that z into a y. Times the derivative of the stuff. Here the derivative of the stuff is 0, because x is a constant in this situation, plus 3z squared times del z del x. Plus the derivative of y squared, which is 2y. I feel like I might have made a mistake with the backside here. Let me check. Ouch! Shoot, I did that last time and it almost really hurt myself. No, I didn't make that mistake. Okay, good. Yeah, we got that. So, oh, but that's zy, not the zx. Sorry about that. Right, so different with respect to y. So then we do the same sort of algebra. I'm trying to get these terms on the same side, right? All the things with y, zy. I don't have to distribute here, so I can just bring, like, say I've got zy times xy minus all of this without the zy. So that's 3z squared over x squared plus z cubed equal to the 2y that's over here minus the xz from over here. Divide both sides by this. So our del z del x, del z del y, or zx, zy if you prefer, is that divided by that. So 2y minus xz divided by xy minus 3z squared over x squared plus z cubed. And then you could multiply by x squared plus z cubed on top and bottom, so you don't have fractions in fractions. On top is going to be kind of gross. Let's do the bottom first. So the bottom is going to be xy times x squared plus z cubed is going to be x cubed y. Right, that's that times that. And then xyz cubed. And then minus this times that is going to be just minus 3z squared. And that's all of this times all of that. And then on top you have to FOIL that, so you get 2yx squared, or 2x squared y. You get 2yz cubed. That's not there. You get minus xz times x squared is minus x cubed z. And minus xz times z cubed is minus xz to the 4th. So that's how you would do an example like that with implicit differentiation. Hope that helps clarify things.